And also, and also Pak Miki give a very old hypothesis test, but maybe we will have a look together, or you can do it after this class. But it's very old, but very useful for us to understand about hypothesis test. And also, there's also learning video in Bahasa Indonesia if you're interested. And this is with Pak Miki, who explained the hypothesis test atau uji hipotesis, right? Okay, so have a look, and then but before we check the videos, let me maybe just explain a little bit about what is hypothesis test. All right, everyone, can you see my screen? Can you see my screen? Yes?
Yes, ma'am.
Okay, thank you. Right. First we're gonna learn about the fundamental why we need hypothesis testing. Yeah. Can you remember? Can you let me know what have you learned in the previous chapter? What have you learned in the previous chapter? Come on.
We learned about statistical interference.
Okay, okay, Jilan, right. Statistical interference. Let me write it. Yeah. Inference, right? What are the parameters that you learn? Who want to add? Jilan, what have you learned? What are the parameters that you learn in statistical inference?
Do you mean like the confidence intervals, ma'am?
Yeah, right. We learned about confidence interval, and there are two types of confidence interval, right?
Yes, the mean and the variance.
Means and the variance. Okay, and yeah, usually we have 95% confidence interval, yeah, 95%, which is alpha equal to 0.05, yeah, something like that. Okay, and actually the hypothesis test, this is for the parameter, is also part of this. So we're actually still in the big chapter of type of statistical interference, which is hypothesis test. The hypothesis. Yeah, and also if you remember, there are two types of samples. Yeah, there's a small samples and also for large samples. Remember, if you have a large sample, you use Z distribution. If you have a small sample, you use a T distribution. Yeah, yeah, for example, for in the exam. Right. So let's go back to here. So what is hypothesis test definition? The hypothesis test definition is actually, so what is hypothesis statistics? It is actually the statement or claim regarding the parameters of one or more population. Is it comply with this or is it not comply with this? Yeah, so that is a statement and claim. Okay, to be able to understand that we accept the hypothesis or not, we use a procedure. The procedure is called hypothesis testing. Okay, and it is widely used in R&D as well as the product and process design. How to justify or saying that this product meets specification or doesn't meet specification based on of the product that we have, for example, we have built or we have produced over the time. We want to check is it still on spec or not. So we still use it is used in research and development and also product design. Okay, and then the hypothesis test is conducted in population and then in not samples. Yeah. Why we have to do hypothesis testing is because the uncertainty in the measurement. Sometimes we have random variables, maybe random errors, and when we do the, for example, we want to do the mean in one in this batch or in one time, maybe it would change in other time. Okay. So let me, I think it would be good if we can describe this. This is quite abstract, to be honest, but we can learn using a lot of examples. So before we watch the videos, let me explain as well and then give some examples about this one. Yeah. So you're in semester 3, so you semester 3, yeah? Okay, so last year you were in TPB, very general engineering, and then in this semester you're just introduced to the chemical engineering area. So that's fine. So then maybe we will, and there's a number example of chemical engineering here. So I'll explain some of the examples. Right. Yes. So for example, this one. This is ASTM, American Society of Testing Measurement, which is the international standard to test something. Yeah. So everything in chemical engineering, in oil and gas, there is a procedure for that. Yeah. And then ASTM is with the code B368 is a corrosion test. That is all in general internationally. So if we do the corrosion test, comply with this ASTM, so it can be recognized internationally. So for example, we have this is called stainless steel. And then here we have a 3 method of corrosion protection for metal pipes. And then the question is, are the 3 methods are equally effective, or is the corrosion rate is still within threshold? Okay, so please, sometimes don't believe very quickly with the statement of a limited evidence. So we have to have the evidence to say that all right, so this this is effective or this is not effective. So how we say that with evidence and then with hypothesis. So hypothesis tests help us to justify the conclusion for things that we claim. Okay. Right. Okay. So this is actually the procedure, but before that, right. Let me, okay, I think it's better if I use the other PowerPoint. I will use the long one that Pak Miki has. So because in the video lecture it's a very quite, I mean it's quite short, yeah, it's a short video. So I'm gonna use the long one. But it's basically it's all similar. Right. Yeah. Okay. Yeah, I think this one. Right. Okay. So, for example, this one. Okay. So, yeah. So the statistical hypothesis is a statement about the parameters of one or more population. For example, we have, or it can be one population, it can be two population, or it can be three population. Yeah. This is an example for two population. For example, the first one we have a control of a plant that use the media is the biochar, only 0.00%, and then this one is 40% biochar for volume per volume, and then how to say for example which one is the better, we have to check it with some evidence in both population. Okay. And also, for example, this is the one that claim of the car. For example, the amount of the liter of the gasoline that use. For example, this is the advertise. 1-2 liter cars can be up to 60, but for example, the actual is 38. For example, so sometimes the real information or the real data sometimes doesn't comply with the advertise or with the claim. Yeah, okay. So how to say that it can maybe can promote or it can support the claim or not? We're gonna use that one. Okay, right. So this is a hypothesis statement. For example, we suppose that we're interested in burning a rate of a solid propellant. Yeah, so the solid propellant is used to power aircraft escape system. Okay, and we call it that the burning rate is a random variables, and then it can describe by the probability distribution. Okay, and then suppose that our interest is focus the mean burning rate or the rata-rata, yeah, the mean burning rate parameter for distribution. So they burn a number of samples and then check them and then check the mean burning rate. Okay, and especially we want to we have a claim or we're very interested in deciding. We want to check whether the mean burning rate is 50 centimeter per second or not. Yeah, we want to know or we want to decide if the mean burning rate of this solid propellant is 50% or not. Okay, so the procedure, we have a null hypothesis. Or HO, null, yeah. The HO is actually the mathematical formulation, kalimat matematika, which contains similarity. Kalimat matematika yang mengandung persamaan. Okay, so here we have the statement that we have. We are interested if deciding whether or not the mean burning rate is 50 centimeter per second. Kita ingin tahu apakah laju rata-rata pembakaran adalah 50 cm per jam, per second. Right? Okay. So the first one, we want to have a hypothesis HO, which is equal to it contains similarity, mengandung kesamaan. For example, this one is mu, which is the mean of the samples. Remember, mu is the mean of the mean of the population. Okay, and the second one is the H1, the second alternative. Yeah, the second hypothesis, which is based on this statement, berdasarkan pernyataan ini, apa yang tidak sama, ya, In this case, we're interested in deciding whether or not the mean burning rate is 50 centimeter per second. Sama atau tidak, ya? Because the parameter say whether or not, ya, which is tidak, ya. So in mathematical relationship, it's become it's not equal to, ya, tidak sama dengan. Okay, so then we have HO null hypothesis, which is mu equal to 50 centimeters per second, and the H1 mu is not equal to 50 centimeters per second. Okay, so the statement of HO mu equal to 50 centimeters per second in equation 4.5 here is called the null hypothesis. Okay, so there's a null hypothesis, and the second one, the H1 mu equal to minus 50 is called alternative hypothesis. Okay, that one there. Okay, so because the alternative hypothesis specific value could be greater or less than, yeah, see, it can be greater or less than, it's called two-side alternative hypothesis. Why it's called two-side alternative hypothesis? Because if you remember about the Gaussian there, okay, we want to know is it lies inside the curve, ya, di tengah-tengah masuk kolam lonceng atau di luar. Okay, so then it can be greater or less than 50 centimeters, which is called two-side hypothesis. Now this one there. This is called, maybe I would draw it, make it better. Yeah, it can be like this. This is called two-sided or two-tailed, or this is if this one is two-sided, or we can also wish the formula one-sided alternative hypothesis, as in the HO, the null hypothesis is mu equal to 50 centimeter per second, H1 equal to minus, less than, yeah. If it is less than, so it is would be one-side hypothesis, one-side tailed, or over here more than that is about one-side tail, but on the right. Okay, so that is an example of hypothesis. How to now, how to test if our hypothesis lies on this area, for example, for Z distribution or not? Then we will need more information. Yeah, for example, the sample mean, we know the standard deviation, and then we're gonna check with the Z, is it lies in the that area or not. Let me check if we have the procedure over here. Oh yeah, okay. Yeah, okay. So yeah. Okay. Right. Up to here, any questions? Still confused? That's all right. We're gonna go a few more slides, and then we're gonna open the discussion, and then to strengthen our understanding, then we're gonna watch the video. Okay, right. Okay, so so the first things first. So how to construct the hypothesis statement? Yeah, how to construct the hypothesis statement. So we have to write the original claim in a sentence form, and then we convert it into a mathematical form. So that is our claim, the right claim, yeah, the claim that we want to put. Okay, and then construct the mathematical form of the statement that will be true if the original claim is false. For example, so the H0 or the null hypothesis always contain equality, yeah, similarity, equality, equal to, sama dengan, yeah, while the H1, the alternative hypothesis, will contain inequality. Okay, for example, we call it steam coal. Yeah, why we call it steam coal? Maybe with just the name, it contains quite a lot number of carbon, water. Yeah, water content in here, and then we use steam coal for boiler to produce electricity. Okay, so this is a picture of coal in a kapal tongkang, yeah, if you know about that, a kapal tongkang, and then they just take some of samples here with the truck. So for example, this one, the steam coal product sold by XYZ mining company has a calorific value of 4,000 kilocalorie per kilogram, right? So let's check with the number one example. So in one example, what is your null hypothesis? So he claimed that the steam coal of the XYZ mining company should be is not less than 4,000 kilocalorie per gram. So what is the mu that is claimed by the company of the steam coal? Remember, null hypothesis will contain equality. Yeah, so mu equal to. Anyone want to help me?
Guys, please turn on your cameras, okay?
Oh, Pak Miki is here.
Yeah, I will be here until 8:30. Right. Well, actually, yeah, around 8. I will leave at 8:30.
Come on. So first, the claim.
We want to see if you're awake, okay?
Yeah, yeah. Thank you. Okay. The clue H0 or the null hypothesis always contain equality, kesamaan, kalimat matematika. Yeah. Okay, so the steam coal product sold by XYZ mining company has a calorific value not less than 4,000 calorie per kilogram. Okay, so because while this is a claim, let's change it into a mathematical equation. Kita ubah jadi kalimat matematika. Okay, so what is the mu? Which is the mean of the population that we claim based on this sentence. Yes? Anyone?
Is it 4,000 or?
Yeah, that's right. Okay, Azra. So there is 4,000. Where is mine? Okay. Wait. I think I have to make it full screen first with me. Then I can. Okay. Right. So this is our claim, yeah. The H0, H0, the null hypothesis contain equality. So this is our claim. The second one, H1. What is the claim? which is contain alternative. Yeah. So if we go back here, H1 contain the alternative hypothesis. Yeah. So what is the alternative hypothesis in here?
N equal to 4,000, Miss.
In equal or okay, in equal. The others?
Less than 4,000 and more than 4,000.
Right. Look at the sentence ya. Lihat pernyataannya. Should not less than 4,000. So, what should we put it? Not equal to or larger or which one?
Larger, yes.
Larger. Okay. Yeah. So yeah. So good. So this is the hypothesis that we construct based on the pernyataan, or based on the claim. Yeah.
Bu Winny, can I interrupt for a second?
Right. Okay, Pak Miki.
Okay, so let's follow this one by one. Okay, so you see in the bullet points above. Okay, we have 1, 2, 3, 4 steps. Okay, so in the first example, so what is the original claim that the company wants to prove here? For number one, for example number one. So all you have to do is just read the sentence. Okay, so the claim, okay, the original claim that the company wants to prove is that the steam, their coal, okay, has a heating value not less. Now pay close attention to the word not less than 4,000 kilocalorie per kilogram.
Salah.
Okay, so that is the original statement. That is the original claim. Okay, not less. So that would be. So now let's not worry about the H null and H alternative first. Okay, so just take a look at this statement. Okay, so the company wants to prove, or the company claims, okay, that the coal has a heating value not less than 4,000 kilocalorie per kilogram. Okay, and then we change this verbal statement into mathematical form. So this would be mu. So what's the sign? Is it equal to or less than equal to or more than or equal to? So when the company says their coal, the heating value of their coal is not less than 4,000. So what is the sign there? Tandanya apa? Sama dengan, lebih besar sama dengan, lebih kecil sama dengan, lebih besar, lebih kecil, not less than. Remember?
More than equal to, sir?
Yes. Okay, so the original statement, okay, so the original statement, mu, lebih besar sama dengan, sorry, I'm saying this in Indonesian, it's shorter, mu lebih besar sama dengan 4.000. Okay, so that is the original claim.
Right.
Yeah. Now, if that claim is not true, then the statement that will become true is its logical, what do you call it, complement, pernyataan pelengkap logikanya. Ya, jadi kalau klaim perusahaan ini salah, maka yang menjadi benar adalah komplementernya, yaitu mu apa? So the first claim is mu is larger than or equal to 4,000. So if that's wrong, then the statement that becomes correct will be mu
Less than.
Equals to less than.
Less
sir.
than. Yes, correct. So the second statement, or the second the statement that will be true if the claim is wrong, is mu less than 4,000. Now, so we have two statements now. Okay, among these two statements, we have to choose which one contains equality and which one contains inequality. Ya, jadi dari dua pernyataan ini, ingat kita belum bicara H0 dan H1. Ya, jadi dari dua pernyataan ini kita pilih mana yang mengandung kesamaan dan mana yang mengandung ketidaksamaan. So the one that contains equality statement is of course the original claim, because that's not less than. Ya, jadi tandanya adalah lebih besar sama dengan. So the first statement becomes the null hypothesis. And if the first statement becomes the null hypothesis, then automatically the second statement becomes the alternative hypothesis.
Right. Okay.
Now,
So,
sudah jelas sampai di situ?
yeah. So Pak Walmiki, so we have to construct the mathematical form first, and after that, we decide which one is the null hypothesis and which one the alternative. Yeah.
Yes.
Right. So we have to write something like this first, and then after that, we go back to the first steps here to put this is because it contain kesamaan, yeah, it contain equality, so this is H0. Oh, okay, thank you very much. Okay.
Now be careful with the when you guys read older textbooks, like older meaning older than me, okay, so really old textbooks, they still allow the null hypothesis to contain tanda sama dengan atau tanda lebih besar atau tanda lebih kecil. Jadi kalau kalian baca buku teks yang lama, H0 itu tandanya boleh lebih besar sama dengan atau lebih kecil sama dengan. Okay, but if you read the newer books, H0, okay, null hypothesis is always written using the sign equal to, because that will avoid confusion when you draw the conclusion later on. Okay, so even though the original claim was mu larger than or equal to 4,000, when you change it into H0, you have to change the sign into equal. Okay. Ya, jadi ini saya ulangi dalam bahasa Indonesia. Kalau kalian baca buku teks yang lama banget, H0 itu tandanya boleh lebih kecil sama dengan, lebih besar sama dengan. Nah, ini akan membingungkan nanti pada saat mengambil kesimpulan akhir. Jadi kalau kalian baca, jadi di buku-buku yang lebih baru, termasuk buku kita, H0 itu aturannya adalah harus tandanya sama dengan. Meskipun klaimnya meskipun klaim yang kemudian kita jadikan H0 itu tandanya lebih besar sama dengan, pada saat kita menulis dia sebagai H0, tandanya harus diubah menjadi sama dengan.
Okay. So, Walmiki, about this case, how should we change it, the H0 and H1? Because you said it should be sama dengan over here.
Yeah. So we simply change the sign from larger than or equal to equal to.
Oh, okay. So this, we should write it as mu equal to 4.
Yes. Yep.
Like that. Okay. And then H1 is just less than. Okay. Right. Okay.
Now, is anybody confused yet about what we're actually doing? Okay. Why we need to do all of this?
Or maybe, Walmiki, do you want to change the explanation with your presentation?
No, I don't have any. This is my presentation, but I can do just some live scratching using my tablet. Okay, jadi saya jelasin konsepnya aja ya. Ini kalau presentasinya sih sama aja yang dipakai Bu Winny ini.
Okay, I'm gonna stop the presentation and then going back to you.
Just so you guys don't get lost about what is actually what we're doing. Why is there any specific reason for this, this insanity? Okay. Because statisticians like to say, okay, is 10 equal to 12? Well, we cannot say for certain in statistic if 10 is equal to 12 or not. Okay, if that's a measurement result. So I'm gonna give you guys some, the mental picture about this whole thing in statistical inference. Okay, the reason why we need all of this is actually basically going back to the notion of uncertainty. Okay. Okay, here we go. Let us start with a blank slate here. Now, okay, let's use blue color. All right. So now, let's say, for example, that let's pick an example that you can relate from your everyday life. Let's say that you are working in a teh botol company, okay, in a company that makes drinks, okay, bottle drinks, pucuk harmo, whatever, okay. And one of the parameters that you guys have to check every day is how much liquid is actually being pumped into each bottle. Ya, jadi salah satu hal yang harus kalian perhatikan sebagai engineer yang kerja di pabrik teh tadi adalah sebetulnya isinya berapa sih, ya. So Of course, if you look at the container, okay, so this is some brand of tea, okay, and of course, by law, the company has to write the liquid volume, the volume of the liquid that is contained in the bottle, right? So you might see something like perhaps 300 milliliters, okay? So this would be the nominal value. Okay, this is the set point. This is the value that your company is aiming for. Okay. Now, of course, this is not a tea is hardly a precision product. Jadi yang namanya minuman makanan itu kan bukan produk presisi ya. Company itu nggak harus mengendalikan sampai ketat sekali sehingga semuanya tuh eksak 300,0 ml. So there's gonna be some variation which leads to frequency distribution. Okay, so if we look at the volume, okay, volume per bottle, because this is well, you can say that this is probably not. You don't really have to control it really strictly. There's no way that a company can achieve exactly 300.000 milliliter for each of their bottle. Okay, so inevitably there will be some distribution, right? Okay. And well, okay, we hope, okay, or the company hopes at least, or the company claims that the average of the population, so this would be the population, okay? This is the population frequency distribution for volume per bottle. Remember, this is population. So this would be measured, this is the behavior of all the bottles that is being produced by the company each day, each week, or so on. So you can imagine that this population will be very large, okay? And the company, based on their measurement, because this is an easily measured quantity, let's say that the company has been around for years. So they have thousands or if not even millions of data points. So every day from their factory, they pick up maybe 10 or 20 bottles, and then they pour the content in the lab and measure the actual volume contained in each bottle. Okay, because they do that year after year, then they will get thousands or even millions of data points. So they are fairly sure that they can measure mu and sigma. Okay, remember, mu and sigma are descriptors of population, not sample. Okay, but because the sample size is so large, then the company they assume that they know mu and sigma. So let's say that the mu, the population average, let's say this is probably 300, let's say 302 milliliter. Okay, and that is they say that okay, this is still okay. This is slightly above 300, but that's okay. Okay. And again, because they have large data, then they can claim that they also know sigma. Say the sigma is maybe like so, okay? So the standard deviation of the population is 10 milliliter. So now we have two data descriptors, ya. Kita punya dua besaran mencari data, rata-rata dan simpangan baku, ya, ukuran pusat dan ukuran sebaran. Now, imagine that you're a new engineer and you are tasked with installing a new production line. Ya, jadi kalian sebagai engineer kemudian ditugaskan menginstalasi jalur pengisian yang baru. Okay, so of course you have to test the filling station, right? Whether the filling station is able to fulfill the target, to approach the target of 300 milliliter or 302. Okay, so in other words, you are tasked with checking if the new production line behaving similarly to the older production lines, or do the new production line deviate from the rest of the factory. Ya, jadi kalian diminta untuk ngecek apakah jalur produksi yang baru ini menyimpang nggak kelakuannya dari seluruh pabrik. Okay, so what you do then is if you take a sample, okay, you take a sample of, let's say, you let the new production line run, and you take a sample of maybe let's say 30 bottles, for example, maybe. Okay, so you have n or maybe 50. Okay, so n is 50. So you have what is called a large sample because n is greater than 30. Okay, the sample size is larger than 30. So you have what is called in statistics large sample problem. Ya, jadi dalam statistika kalau ukuran sampel, berarti kan ukuran sampel bukan jumlah sampel. Ukuran sampel lebih dari 30 maka itu dikatakan sebagai sampel besar. Okay, so you remember this hopefully from the exam. Okay, from the confidence interval. So, and then you measure. Okay, you measure the average filling volume of that 50 bottles, and you found this to be. Remember, this is X bar. This is not mu because this is sample, not population. And you found the average filling volume of that 50 bottles to be 300. Let's say I'm just picking up a number here. Okay, 350 milliliters. Okay, and this is measured from 50 bottles. So you get alarm, ya. Jadi kalian kemudian waspada gitu. Waduh, ini kok isinya banyak sekali. Oke, kenapa kok dia jauh lebih tinggi dari rata-rata pabrik? So you got panic and you report to your supervisor and show him or her these numbers. Waduh Pak atau Bu, ternyata mesin yang baru nih, jalur yang baru nih kayaknya kebanyakan deh isinya, ya. Rata-ratanya 315 ml dari sampel yang ukurannya 50. Okay. With let's say, I forgot one thing here. Okay, so the standard deviation of the sample. Sorry, I forgot about this. The standard deviation of the sample is, let's say, 15. Okay, 15 milliliter. Again, pay attention to the symbol here. I'm writing it down as S, not sigma, but S. So S is sample standard deviation. Okay, so you got panic and you report to your supervisor, and your supervisor calms you by saying, okay, let's not get carried away, ya. Jangan terburu-buru mengambil kesimpulan. Lihat dulu, ya. The thing that you need to check is actually whether this behavior represents a deviation from the overall behavior of the population, right? Okay, and when you want to check that, you have to take into account that your experiment varies, your observation varies. Jadi kalau percobaan ini kalian ulangi lagi, mungkin besok atau 2 hari lagi, belum tentu kalian dapat angka yang sama. Ya, jadi selalu ada ketidakpastian. Ya. You might get a different number for the average, or standard deviation, or both, the next time you do this kind of experiment. Okay. So what we want to do then, again, using this hypothesis testing, is we want to check if this represents a deviation from the population. And this is the population, okay? So the population is characterized by these two numbers, okay? The population mean is 302. The population standard deviation is 10. And you want to check if these numbers are significantly different or statistically different from those numbers. Okay, we do that by hypothesis test. Okay, now depending on your need, ya, jadi tergantung keperluan kalian, you might in some cases you might be interested in only checking this one, the average, or in some cases you just want to check the variance or the standard deviation. That's fine. It really depends on the problem. Okay, or in some cases you need to check both. Okay, maybe your boss wants you to check both. Okay, jadi mungkin saja atasan kalian itu meminta kalian memeriksa dua-duanya, ukuran pusatnya dicek, ukuran sebenarnya dicek. Mungkin untuk kasus tertentu kalian hanya berkepentingan untuk ngecek variansnya atau hanya rata-ratanya. Nah, itu tergantung dari keperluan. Okay. Right? Again, jadi mengapa kita perlu uji hipotesis? Karena adanya uncertainty. Okay, this is really the only reason why we need statistics, because we have measurement uncertainty. Because these numbers, now remember you guys, these numbers are all random variables, meaning you don't only God knows the values before you guys do the experiment. Okay, so we have no way of knowing what numbers we're gonna get until after we're done with the measurement. So we call these numbers random numbers or random variables. By random, I'm not saying that the measurement is done erratically, no, but it simply says that we don't know the value of those numbers before we do the measurement. Ya, jadi kita nggak tahu. Misalkan sekarang besok kalian melakukan pengukuran sama, kalian ngambil 50 botol lagi, kalian ukur volumenya, yakin dapat 315 besok? Nggak bisa, ya. Oke. Okay, so with that in mind, I hope you guys have a better idea of what we're actually doing. Okay, why we need all of this this method is really because of the uncertainty. Okay, measurements differ, results will vary, observations will vary from time to time. Okay, errors will be made. There will be some errors in measurement, inevitably. There will be some inaccuracies, imprecisions. So we cannot predict what result that we're going to have. Okay. Okay, thank you.
Okay. Thank you very much, Pak Miki. Let me put the screenshot here so we can use it as an example, maybe, Pak Miki, for the next time to solve the problem. Okay, right. Okay, everyone. So let's continue our presentation. Give me a few seconds. Wait. Okay, let's go back. Oops, not this one. That. Okay, let's go. Yeah. All right. Okay, thank you, Pak Miki, for putting more. Okay. Yeah. Let's go back there. Okay. So another one. This is an example. Yeah. Go back there, right? Okay. Another one, for example, this one is another case. For example, with this picture, we have a total oil and lipid content of wastewater produced by PT ABC, yeah, PT ABC, a palm mill oil plant, and less threshold Permen Peraturan Menteri Lingkungan Hidup number 5, the year 2014, namely, for example, 25 milligram per liter. So this is also the claim. Using the experience before, let's together first write the mathematical form. So what is the mathematical form of the second claim here? Would you like to help me?
Ma'am, is it mu is less than equals to 25?
Right, so this one is less than the threshold, yeah, less than, namely 25, so less than, yeah, okay. So this would be the 25. And how about the complementary statement? The second one.
More than, ma'am.
More than 25, okay. And then with that, So first, okay, so write down your original claim. So this one's done. The second one, convert the sentence into mathematical form. So this one is the mathematical form. And then construct the mathematical form that will be true if the original claim is false. And after that, we choose the null hypothesis. So what is the null hypothesis? That contain equality, yeah. But Pak Miki said in the new books, we don't put the lebih besar sama dengan, so we just put the equality, yeah. And then so the H0 equal to mu equal to
25.
25, and the common complementary statement, the claim that we construct from the previously, yeah, from this sentence, then we put it equal to more than 25. Okay, so this is for the mean, like Pak Miki said before, but sometimes we also interested with the variance, and maybe then we're gonna learn also about the hypothetical test for variance. Right. Now, this one is also tells you about the hypothesis one side or two side, where if, for example, if the claim said, for example, here, like here, yeah, sorry, like this one. Okay, so we're interested in deciding whether the mean burning rate is 50 centimeters or not, yeah, per second. So the equal statement we will say equal to 50, while the alternative statement, the alternative hypothesis tells you not equal to, ketidaksamaan, ya. If it is not equal to, tidak sama dengan, then it is a two-side tails, yeah, and go back to here, yeah. So this one here. Okay, so the hypothesis testing, it can be one-sided or two-sided, yeah. So it's based on the H1 statement. So go back to the H1 statement that in our previous case, for example, for the steam coal or for the effluent mill, yeah, the second previous one. If it is two-sided hypothesis, the H0 equal to mu, yeah, mu 0, for example, mu equal to mu 0, and the H1 mu not equal to mu 0. So we have two side tails. Okay, and sorry, this is one side, yeah. This one is one side, and this one is two sides, yeah. Which is this is the area where we didn't reject null hypothesis. The two tail reject the two hypotheses. Okay, different. Let's change the picture. Oh, picture it look like this anyway. Right. And for one-sided hypothesis, the rejection would be on the left or the lower, and also on the right or the upper side. Yeah. If it is lower than lower here, so maybe the H1, the mu less than mu 0, for example. And if on the right, the H1 equal, for example, mu more than mu 0. All right. This one, maybe Pak Walmiki want to explain with a nice explanation about the wrong conclusion, Pak Miki. Hello, Pak Miki, are you there? Okay, anyway. Okay, I'm gonna explain. Okay, so in the hypothesis testing, the rejection of null hypothesis H0 is called the strong conclusion. So if we reject null hypothesis H0, is called strong conclusion, while on the other side, if we do not reject H0, is called weak conclusion. Okay, and in formulating hypothesis statement, we should put statement which is important to make strong conclusion in alternative of hypothesis compared to H1. Okay, so this is an example. Yeah, so how we define H0 and H1 is important for us, so we have a strong conclusion. So let's see this one, yeah, an example. So suppose a soft drink bottler will purchase a 2-liter bottle from a glass company, okay? And then the bottler want to sure that the bottles are meets specification of the internal pressure in the bursting strength, which is minimum of 200 psi. And then the butler decided to formulate decision for a specific problems. Yeah, for example, the null hypothesis, of course, equal to 200 psi, and H1 is more than 200 psi, or the first one equal to, and the H1 is less than. So what do you think based on this one, which lead to a strong conclusion? Which one, the formulation that we choose, is it this one or the second one? So what do you think? So the bottles needs to meet the specification should be a minimum strength of 200 psi, so minimum strength. So what do you think? So which one do you think the alternative hypothesis that better, yeah, compared to the other?
Is it the second one, Miss? Ma'am?
The second one?
Yeah.
Okay, how about the other? Why, Azra?
No, because it says is a minimum strength of 200 psi, so minimum. So I'm guessing it should be 200 or more for the H0.
Right. So because it is more than that, so this is the alternate, yeah. So that is the alternate, so should be less than, yeah, yeah. So yeah, that's just an example, right? That is true. Okay. Anyone who also agree with Azra? Okay, so yeah, again, go back here, look at the statement, yeah, one by one, and then usually, so what is the, for example, for this case, what is the real statement in this one? So mu equal to less than, yeah, so actually the first, the claim, it should be minimum strength, should be more than 200, yeah. So that is the first claim, and then the second one, the alternate hypothesis would be less than 200, yeah. So that's right answer. But because in the new book there is no more than, so we change it into equal to, right? Okay. So again, it is go back. This is actually similar with the previous one. We have discuss this one. So first we have to find also the significance alpha, yeah, the significance level of for alpha for the decision making. Is it 90%? Is it 95%? Or is it 99%? And then the second one, we state the H0 and also the H1. And after that, we're gonna check the statistic test. If the sample is large enough, we can use a Z statistic. If the sample is small, we can use the T table, yeah, the T distribution. Okay, and after that, let's calculate the critical value, which is bound to rejection to H0 based on the alpha. And after that, with that, we define if the testing, if we reject or accept the region. Okay, and then we put the formulate the conclusion. Is it not enough evidence to reject H0 or not enough to evidence to reject H0? Okay, with that we have videos from Pak Walmiki. So I think it's good if we watch together. So give me 1 second to let's open your EduNext. Okay, let's watch the videos there. Okay, there, if you open your EduNext there, oops, and this one, yeah, let's okay, let's watch the video. Oops, go back there. About an example of uji hypothesis, yeah. But I'm sorry, this is in Indonesian, yeah.
Selamat datang di kuliah TK2105 Statistika Teknik Kimia dari program studi sarjana Teknik Kimia IPB. Dalam video segmen kali ini kita akan membahas beberapa contoh soal uji hipotesis untuk cuplikan tunggal. Mari kita mulai. Kasus pertama yang kita bahas adalah uji hipotesis untuk rata populasi dengan simpangan baku populasinya diketahui. Atau cuplikannya besar. Ini adalah dua situasi yang kurang lebih penanganannya sama, yaitu kita menggunakan statistik uji Z0. Soal cerita yang kita bahas kali ini adalah mengenai standar produk semen, ya. Jadi menurut SNI, Standar Nasional Indonesia, berat produk semen Portland komposit yang dikemas dalam kantong kertas atau dalam istilah sehari-hari dikenal sebagai sak semen, ya, ini adalah 20, 40, atau 50 kg per kantong. Dan SNI juga mengatur antara lain bahwa kekurangan berat tidak boleh melebihi 2% dari berat yang tertera pada kantong. Sebuah pabrik semen ini ingin memastikan bahwa rata-rata output dari pengantongan mereka untuk produk ukuran 40 kilo ini tidak kurang dari 39,2. Untuk itu diambil satu cuplikan produk yang terdiri dari 20 sak semen. Kemudian cuplikan tadi diukur, rata-rata beratnya diperoleh angka 38,9 kg per sak. Dan dari data historis pengorbanan pabrik didapatkan bahwa simpangan baku output pabrik, jadi di sini kita anggap kita mengetahui sigma berdasarkan pencatatan historis, yaitu 0,85 kg. Nah, kita diminta untuk membuktikan bahwa pada tingkat keberhasilan 5% bahwa pabrik tidak melanggar SNI tadi. Ya. Pertama-tama kita menyusun.
Let me pause a little bit. Okay, so here, biar nggak terlalu cepat ya. So first, we see here ya, in Indonesia, ada berat kantong memastikan bahwa dia ingin memastikan bahwa rata-rata dari kantong semennya yang ukuran 40 kilo itu tidak kurang dari 39,2. Jadi walaupun dia bilang memang aslinya 40 kg, tapi pasti ada plus minusnya ya, ada variasinya. Maka mereka ingin memastikan bahwa yang ukuran semen mereka tidak kurang dari 39,2. Untuk mengetahui itu, mereka ambil sampel cuplikan, ya. They find samples about 20 sack of cement, yeah. So they check 20 sacks of cement, and then this the samples shows that the mean of the samples, rata-rata berat cuplikan is actually 38.9, 38,9, ya. And then with the historical data, because like Pamiki said that it is they have a lot of data, yeah, for a while after a while, and then the simpangan baku or the simpangan baku the standard deviation of those plant is 0.85. Okay, so remember here we have an example. This is the claim. Yeah, should be less than 39.2. And then to check the claim, if the claim is we support the claim or not, we have to get the samples. And then we get the samples with the n equal to 20. Yeah, it's quite a large number. And then also we have the standard deviation, and also we have the rata-rata, the mean. Okay. We're gonna learn with the example first, and then we go back to the material. Okay, so it's so you may learn with the application first, and then after this we're gonna go back with the hypothesis for the means. Okay.
% bahwa pabrik tidak melanggar SNI tadi. Ya. Pertama-tama kita menyusun terlebih dahulu klaim. Ya, kita tidak boleh meremehkan pentingnya menyusun klaim yang benar, karena kalau klaimnya tidak kita susun dengan benar, maka hipotesis nol dan hipotesis alternatifnya pun juga tidak akan tepat penyusunannya. Ujung-ujungnya adalah kesimpulan yang diambil juga tidak tepat. Klaim awal yang ingin dibuktikan bahwa rata-rata berat pengisian PCC ini adalah tidak kurang dari 39,2 kg per kantong. Nah, dalam bahasa matematik ini menjadi pernyataan demikian ya. Mu lebih besar sama dengan 39,2. Nah, jika klaim ini salah, maka pernyataan yang menjadi benar adalah komplementernya, yaitu mu kurang dari 39,2. Oke, kemudian berikutnya dari dua pernyataan 1 dan 2, ini kita pilih. Pernyataan yang mengandung kesamaan kita pasang sebagai H0 dan yang mengandung ketidaksamaan sebagai H1. Ya, maka hipotesis untuk masalah ini adalah seperti demikian. Kemudian dari soal kita mendapatkan rata cuplikannya adalah 38,9 kg per sak dengan simpangan baku populasi. Jadi ini bukan simpangan baku sampel, tetapi simpangan baku populasi kita anggap diketahui, yaitu 0,85 kg. Dan ukuran sampelnya adalah 20. Oke, statistik uji Z0, rumusnya seperti demikian, gampang sekali, tinggal Anda masukkan saja angka-angkanya ya, rata-rata cuplikan, kemudian nilai acuan, ya, simpangan baku populasi, dan akar dari ukuran sampel. Diperoleh angkanya adalah minus 1,578. Berikutnya adalah kita mencari nilai kritik Z untuk alfa 5%, ya, tingkat keberhasilan 5%, dan ini adalah untuk uji satu sisi sebelah kiri, sesuai dengan tanda H1-nya. Z kritiknya adalah minus 1,645. Kalau digambarkan dalam diagram kurva distribusi Z, luas daerah yang diarsir ini adalah 5% sebelah kiri. Ini menggambarkan probabilitas atau menggambarkan letak dari daerah penolakan untuk masalah uji kita ini. Alfanya 5% di sebelah kiri, maka Z kritiknya adalah minus 1,645. Jadi sebelah kiri ini adalah daerah penolakan. Mungkin Anda bisa memikirkan juga bukan sebelah kiri, sebelah kanan, karena kadang-kadang agak membingungkan, tetapi luar dan dalam. Sebelah luar adalah daerah penolakan H0, dan sebelah dalam adalah daerah non penolakan H0. Z ujinya, statistik ujinya ada di sini, minus 1,578. Jadi dia berada di dalam daerah non penolakan H0. Dengan demikian kita simpulkan bahwa tidak terdapat cukup bukti untuk menolak pernyataan H0. Ya, kalau kita elaborasi, tidak terdapat cukup bukti untuk menolak pernyataan bahwa rata-rata massa pengisian kantong tidak kurang dari 39,2 kg per kantong.
Okay. Stop it here ya. Okay. So,
kantong tidak kurang dari 39,2.
Okay. Yeah. Okay. So from these examples, after this we're gonna watch the video about the hypothesis of the mean. But basically, what we to find the solution, first we have to check the samples. Yeah, we have to get the samples. Here we have the n about 20 kantong, yeah, and after that the mean of the samples we check it, and then we use the test for large samples. The large test of the large samples you also have learned before is the Z distribution, right? And then check for your case based on the samples. Here your Z equal to based on the mu x bar minus mu divided by standard deviation per square n, okay? And then with this formula, you got the value about 1.5 around this area, while also you have to write the z critic, yeah, the critical z based on the alpha, based on the confidence level, or based on the alpha here. So we want to find the alpha because it should be in 95%. 1 mean alpha equal to 95%, so the alpha should be 0.05. And because it is one side, yeah, the H1 is one side, then we have to find the area on the tail, the left tail there, atau bagian terluar, about 0.05. Okay, and then we have the z critic is actually minus 1.645. That tells you that the z0 equal to just inside here, but we can't say dengan demikian maka pernyataan itu benar. We can't say that, yeah. We can say, okay, the statement is correct. So statistically, we can't say, oh, pernyataan itu benar. We cannot say that. So we have to say that there is no enough evidence to untuk menolak pernyataan. Okay, so this the statement would be tidak terdapat cukup bukti untuk menolak pernyataan bahwa rata-rata massa pengisian kantong PCC tidak kurang dari 39,2 ya. Look, see, maybe you want to screenshot this screen because this is very important for type of example, yeah. But in statistically, it is very, very long, and then tidak terdapat cukup bukti untuk menolak pernyataan bahwa rata-rata massa pengisian kantong tidak kurang dari 39,2. Okay, up to here. Do you want to have a question first before we watch? We're gonna go back watching the procedure for these big samples. All right, if not, let's go back and then go back to the EduNext, and then let's watch the video from Bu Helen. But now I would like us to watch it together so we can pause, and then if you have a question, you can have a look together. Okay, now let's watch about 7 minutes videos with Bu Helen about one sample hypothesis testing of means, yeah, which is the one that examples that has Walmiki gave to you. Okay, so let's watch together. Sorry, but before that, is my screen is okay? Is it very blur, or is it okay on the screen? Can you see it nicely? Hello?
Yes, ma'am, we can.
Okay. That's what.
Hi, welcome back to Chemical Engineering Statistics. Now, we will learn about how to make one sample hypothesis testing of the mean. So in general, the procedure for hypothesis testing is as follows. First, we have to formulate two statements. One is the initial claim to be proven, and two is the statement that will be true if the initial claim is false. That's what we know as H0 and H1. Then the statement should be converted to mathematical statement, and that's when we have the H0 and H1. After that, we have to determine the confidence level or the significance level alpha. Based on the data, we need to calculate the value of the test statistics. Then, we find the critical value of variables from the table. We need data such as alpha, degree of freedom, and the properties of the hypothesis testing, whether it's one-sided or two-sided hypothesis testing. Next, we compare the statistical testing position and the critical value in the area of rejection or in the area of non-rejection of H no. Lastly, we draw conclusion by referring to the initial claim to be proven. In one sample, hypothesis testing of mean means that we claim testing that compares the population mean with a specific reference value. Some example of the claim is the average score of statistic class final exam participant in the last 3 years is not less than 75. Other example, the average heating value of coal from this mine is not more than 4,500 kilocalories per kilogram. Another example, the average viscosity of brand X lubricating oil in the last 100 production lots is 75 centistocks. Remember that the claims are made against the population parameters, not the sample parameter. In this case, we consider making inferences about the mean of a single population where the variance of the population is known. Suppose that we wish to test the hypothesis where mu0 is a specified constant. Because X has an approximate normal distribution with mean or mu0 and standard deviation sigma divided by square root of n, the statistic test, the Z0, statistic test is Z0, can be calculated as follows. Please note that the subscript 0 indicate the statistical testing parameters for the null hypothesis. In case 2, we consider making inferences about the mean of a single population when we don't know the value of sigma and the samples is small. The step-by-step calculation is similar with the previous case 1, but for case 2, we use the T value and the T table instead of the Z table. The approach of hypothesis testing that we have outlined in the previous section has emphasized using a fixed significance level, alpha, and this value will often be 0.05. This fixed significance level or fixed type 1 error rate approach to hypothesis testing is very nice because it leads directly to the definition of type 2 error. However, fixed significant level does have some disadvantage. For example, suppose that you learn that the null hypothesis regarding the mean burning rate of the rocket propellant has been rejected at 0.05 level of significance. This statement may be inadequate because it gives you no idea about whether the sample average burning rate was just barely in the critical region or whether it was very far into this region. This relates to the strength of the evidence against the null hypothesis. Furthermore, stating the results this way imposes the predefined fixed level of significance on other users of the information. This may be unsatisfactory because some decision makers might be uncomfortable with the risk imposed by choosing alpha 0.05. To avoid these potential difficulties, the p-value approach to hypothesis testing has been widely adopted in practice. So the p-value basically is the probability when H null is rejected. We can compare the significance level with the p-value. If the p-value is less than alpha, then we can reject the null hypothesis. Please have a look on the Montgomery book to learn more about the p-value. That's all for now. Thank you and see you in the next video.
Right. Okay. So everyone, you can have a look on the this one. Where is it? Yeah, okay. So you can have a look. The first case is for the large samples. Yeah. If in a large samples, then you use a Z distribution based on the you know the mean from the samples that we measured. Okay, and then we know the standard deviation, and then we also in the problem there would be a confidence level. Put the confidence level to get the Z critical. Okay, and then you can check which one is in the area of rejection or in the non-rejection. Okay. The second one, if it is for small samples, and then the unknown standard deviation, then you can check this one with the T distribution based on the standard deviation of the variance, based on the variance here of the samples, and then with also putting the degree of freedom. Okay, it looks like how to for you to read the T and then put it into these examples. Okay, and one more, Bu Helen also tells you about the p-value, because sometimes in around the boundary, around the Z critic, sometimes we're not sure enough if is it rejected or is it not? Yeah, even if you look at here is we reject the H null, H0, if we reject the H null, but it's very simple here, very close. So sometimes we also add a p-value there. A p-value is the area over here, yeah, which is the area from Z 0, Z null over here to the infinity over there. So how much the area H0 rejected? Okay, we can calculate it using a Minitab, or we can calculate it also using yeah, check that one there. And then this one is to indicating how far the statistical testing goes into the rejection or non-rejection area. Usually in the experiments, in the tugas akhir, yeah, in the final project, when we want to make sure, or in your lab experiments, to make sure that we have a good, or we have a yeah, it is a good yeah, it is a good example. Then we use a p-value to check, to just ensure. And then in reality, there's some certain p-value, how much, for example, my 0.001, for example, or yeah, some numbers that to be confident enough that we're in a rejected, or we're not rejecting H0, for example, like that. Okay, right. Any questions about the hypothesis of the mean? No? Okay. Now let's watch the video about the testing of variance. If you look at here, there is a 14 minutes video. It's very old videos, but I have watched them last night, and then it was very good and very terlihat, yeah. They put it a very good hypothesis about the lamp, how long like the lamp electrical lamp can can be turned on and then it's gonna broken, for example. It's very nice idea. So you can have a look. Okay, now let's watch the next video about the testing of variance, how to get the variance. Remember, if you use the variance, we're going to use chi-square. So let's have a look.
Hello, welcome back to Chemical Engineering Statistics. In this section, we will discuss about hypothesis testing of variance. Sometimes, the hypothesis testing for the population variance or standard deviation are needed. If we have a random sample x1, x2 until xn, the sample variance S square is an unbiased point estimator of sigma square. When the population is modeled by a normal distribution, the tests and intervals described in this section are applicable. Now suppose that we wish to test the hypothesis that the variance of a normal population sigma square equals to a specified value. x1, x2 until xn are random samples of n observation from this population. The null hypothesis and the alternative hypothesis that we can construct is as follows. We can say that the null hypothesis is sigma square equal to sigma 0 square. And the alternative hypothesis is sigma square is not equal to sigma square to sigma 0 square. For the alternative hypothesis, we can also have more than or less than. The test statistic for the hypothesis testing of variance is what we call as the chi-square. To calculate the chi-square, we can use the equation below. Several chi-square distributions are shown in figure 4.21. Please note that the chi-square random variable is non-negative and the probability distribution is skewed to the right. However, as the k increases, k is the degree of freedom. So as the degree of freedom increases, the distribution becomes more symmetric. At k equal to infinity, the limiting form of the chi-square distribution is the normal distribution. So because we have a symmetric distribution for the chi-square, we cannot determine the critical value by mirroring the minus and positive mark similar to the z or t distribution. So how to get the chi-square value? To get the chi-square value, we can use the chi-square table. It is available in Appendix A, Montgomery book. So just like before, if you look at the figure above, we can look at the shaded area. The shaded area is alpha. So if we do the hypothesis testing with significance level of 5%, means that our alpha is 0.05. In this case, we do one-sided test. When we know that our alpha is 0.05, we need to determine our degree of freedom. Let's say our degree of freedom is 10. So at degree of freedom of 10 and alpha of 0.05, we can find that our chi-square is 18.31. If we have two-sided test, so at 5% significance level, we need to find the area at alpha divided by 2, or at 0.025. The rest is similar with the Z and T table. Here we have one example of the hypothesis testing for variance. In this case, we have an automatic filling machine used to fill bottles with liquid detergent. We know the sample variance to fill volume is 0.0153 fluid ounce square. If the variance of the fill volume exceeds 0.01 fluid ounces square, an acceptable proportion of bottle will be underfilled and overfilled. So the question is there evidence in this sample data to suggest that the manufacturer has a problem with underfill and overfill bottles? We can use alpha 0.05 and assume that the fill volume has a normal distribution. So the procedure is as follows. First, we need to state the parameter of interest. The parameter of interest is the population variance sigma square. The null hypothesis is sigma square equal to 0.01. The alternative hypothesis is sigma square more than 0.01 because the manufacturer will have problem if the variance of the fill volume exceeds 0.01. The test statistics chi-square can be calculated by that equation. So the critical value to reject or to accept the null hypothesis can be found or can be determined by finding the value of chi-square at 0.05 and with 19 degree of freedom. We find that the chi-square value is 30.14. The calculated chi-square is 29.07. So because our calculated chi-square is less than the critical chi-square, we can say that our calculation lies in the non-rejection region. However, because the value is pretty close, we conclude that there is no strong evidence that the variance of fill volume exceeds 0.01. So that's all for today. Thank you and see you in the next video.
Okay. Thank you, everyone. So that is the one hypothesis test of the variance there. Now let's watch. So to go back to the maybe. Okay. So go back there. Let's go back there. Wait. Okay, yeah. Okay, so again, so hypothesis testing of the single sample, yeah, for the variance of a single sample, we're gonna use chi-square, yeah, not a chi-square, but chi-square. Looks like an X like that, and then it is distributed symmetrically and it have a degree of freedom. Okay, so how about the hypothesis testing for the means? What should the distribution that we use for the means? Okay, for the means we use the Z distribution, or where is the distribution? Z distribution. Oh, but for the mean, if the sample is small, or the standard deviation of population is not known, we use the T distribution. We use the T distribution. Okay, so everyone, you have to just to remember again from the exam, there are Z distribution for to get the mean in a large samples. And also there's a T distribution for small samples, and also with no standard deviation of the population, you can use the here with those degree of freedom. And the last one is for a chi distribution table to find the hypothesis testing for the variance. Okay. Lastly, before we finish the session, let's watch another video, the last one, about an example again from Pak Walmiki about the hypothesis of variance. So hopefully after this you're packed up with the concept of hypothesis testing for one samples, for the mean, rata-rata, or also variance. Next week, we're gonna learn about how if we have two samples, yeah, for or two populations. Okay, so let's have a look. Hypothesis. Oh, this is the tutorial. Okay, let's watch. We put it after here, I think. Yeah, okay, let's have a look. Let's watch it.
39,2 kg per kantong. Lanjut ke kasus kedua. Ini adalah uji hipotesis rata populasi dengan simpangan baku populasi yang tidak diketahui dan cuplikannya kecil. Mudah-mudahan masih ingat dari.
We're gonna skip this. We're gonna go the next stage, yeah, the variance. This one. This one is using T distribution. You can have a look later.
Kasus terakhir, uji hipotesis variance. Ya. Di sini kita lanjutkan kasus nomor 1. Pabrik semen mencurigai telah terjadi fluktuasi berat pengantongan yang melebihi simpangan baku historis 0,85 tadi. Untuk memeriksa, dilakukan pengukuran berat terhadap cuplikan yang isinya 12 kantong semen, di mana rata-rata berat per kantong dalam cuplikan itu adalah 39,4 dengan simpangan baku 0,91 kg. Nah, periksa kecurigaan bahwa simpangan baku dari produk sudah melebihi dari nilai historisnya pada tingkat keyakinan 95%. Nah, jadi klaim yang ingin dibuktikan adalah bahwa sigma lebih besar dari 0,85. Ubah ke variance menjadi angkanya demikian ya, 0,722 kg kuadrat. Jika klaim awal salah, maka yang benar adalah variance kurang dari sama dengan 0,722 kg kuadrat. Ya. Seperti biasa, kita lihat bahwa pernyataan nomor 1 mengandung ketaksamaan dan pernyataan nomor 2 mengandung kesamaan. Maka yang nomor 1 menjadi H1, yang pernyataan kedua menjadi H0. Dan dari cuplikan kita mendapatkan simpangan bakunya adalah 0,91 S, ya. Kemudian N-nya sama dengan 12. Statistik ujinya kita menggunakan chi-square, ya, dengan rumus demikian. Sangat simpel, kemudian Anda mendapatkan angka 12,62. Dan seperti biasa yang kita bandingkan dengan nilai kritik. Ya. Nilai kritik chi-square untuk probabilitas 0,05 dan derajat kebebasan 11. Ini probabilitasnya untuk satu sisi sebelah kanan ya, sesuai dengan H1-nya. Nilai kritiknya adalah 19,67. Nah, bagaimana posisi relatif antara statistik uji dengan nilai kritik kalau kita gambar dalam distribusi chi-square seperti demikian. Jadi ini adalah nilai kritiknya ya, dan daerah yang diarsir ini luasnya adalah 5%, satu sisi sebelah kanan sesuai dengan H1 ya. Kemudian statistik ujinya letaknya di sini 12,62. Jadi Anda bisa melihat dengan jelas bahwa statistik uji berada di dalam daerah non penolakan H0. Jadi kita simpulkan tidak terdapat cukup bukti untuk menolak H0. Atau kalau ada elaborasi kata-katanya, tidak terdapat cukup bukti untuk mendukung kecurigaan bahwa varians berat pengantongan telah melampaui nilai historisnya. Oke, jadi ini adalah tutorial kita kali ini dan sampai jumpa di video segmen berikutnya. Terima kasih atas perhatian Anda.
Okay. Yeah, let's have a look. Very fast explanation. But anyway, this is an example of hypothesis test for variance. Here we have, for example, the rata-rata berat kantong, which is x mean, yeah, x mean over there. And also we have a simpangan baku, but because the simpangan baku for this case is for sample, so we call it S, yeah. So S or simpangan baku over there. But then and also the population standard deviation is 0.85. So the sigma square become 0.85 square. Okay, and then this is very interesting that Pak Miki said in this video that we can actually make the first statement as the H1 and the second statement as the H null. It depends which one that those statements have equality. Okay, in this case, the second statement have the equality, so we can write it as the H null in here. Okay, well, the H1 is this one. Okay, everyone. So I think that will should conclude our lecture for today. So let's please have a look. Have a look on these videos. Okay, 2 SKS, yeah, 2 credits means you have 2 hours with me and also with Pak Miki in the class, and you have 2 hours with you by yourself to do studi mandiri, yeah, to do your self study. So please do your self study. Have a look on these examples and also try to do it by yourself. Try to do it by your hand. So hopefully you understand about the hypothesis for 1 samples. And next week we're gonna continue with for 2 variants and 2 samples. All right, before we finish, anyone want to have a questions? No? Okay, that's enough. Okay, so I'm going to conclude this lecture for today. So thank you very much for your attention and have a good day for today. Okay, bye-bye.
Thank you very
Thank
much,
you.
ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.